All right. Hey, Spartans, this is not working for me. I'm going to get a sore back really soon if I do this. So let me straighten this out a little bit and let's see if we can talk a little bit. Hey. Welcome, Spartans. We're going to do a little bit of a demo today. We're going to try seeing if we can learn about temperature um, and the three methods of heat transfer. So there is going to be a quiz on this. You might want to pay attention to the definitions. I'm just saying. All right, so let's go ahead and let's take a look. I'm gonna do this a little bit. Let's see what we see here. This is a hot plate. Well, it's going to be a hot plate right now. It's not a hot plate. I wouldn't be able to do that. So it is cold right now. And we have a beaker that is able to withstand heat. It is Pyrex, and so it's heat resistant. And um, we have some water and a hot plate that isn't hot right now. And let me get this to you. We're trying some new things here, folks. So we want to make sure that everybody has a chance to see how this works and see if we can go ahead and figure out how this whole temperature thing actually kicks in. So this is what we're going to do. We're going to start us off with plugging this bad boy in. And then we're going to talk about what temperature is and how it all works. So you will notice this is the last time I am going to put my hand on here. I'm plugging it in now, and I'm going to turn this thing on. And then we're going to start talking about why this works. What does this actually do? So I'm going to turn this on, and it is going to start heating up. But why? Have you ever thought about why something gets hotter? Oh, Fredericks, it's got electricity going through it. Well, yeah, it does. So, okay. See, I can already start feeling it warming up a little bit. But why? Well, let's talk about that. It all really comes down to what is temperature. Um, temperature. You all have heard that word before, but what is it? Well, Fredericks, it's when something gets hot. Okay, thank you, Einstein. So what? Well, let's look at what the definition of temperature is. How do we know that something is hotter than something else? Well, here's your first definition. Temperature. Temperature is the average molecular kinetic energy of a substance. Okay, this is getting a little too hot. I'm going to turn it down a little bit. So, what does that mean? Well, we started with some coils that were cold, right? I could put my hand right on it. And then I plugged it in and I turned it on. And electricity, which is nothing but a carrier of energy, electricity brought some energy from the wall, from the outlet, through the cord, through the surge protector, and into these coils. You can actually see that they're starting to get glowing hot now. So these are going. But what happens to that? What makes it really hotter? Well, that energy is getting the molecules to move faster and faster. Everything that is above absolute zero, so everything has molecules that are moving. Items that are very cold, like ice, the molecules are moving only a little bit because they don't have a lot of energy. They're stuck together. But then you put additional energy in, like you take an ice cube and set it on the sidewalk, and those molecules start getting more and more energy, and they're actually able to break the bond that holds them together, and they turn into liquid. You give more energy, those molecules move faster and faster, and they can actually evaporate. And they have so much energy that they turn from a solid to a liquid to a gas. But temperature, the average, meaning that you're not looking at that one molecule, right, that's touching the glass, that's touching the coil. You're looking at the general temperature of all the water. So it is the average molecular, the molecules themselves. Kinetic energy, kinetic. Kinetic is the energy of motion. So something that's real cold, the molecules have little motion. Something that is very hot, they have a lot of motion. They can move very rapidly and of any substance. So now you have your first definition. The temperature is the average molecular kinetic energy of a substance. Okay, big deal. So what? Well, now we're going to learn about the three. There are only three types of energy transfer, heat transfer. Temperature is how hot something is. Heat is how it transfers that temperature from that energy, that thermal energy from one to another. So let's take a look at heat transfer. Heat transfer is the movement of thermal energy from one location or one substance to another. Okay, so that energy is going from this wire, that electrical energy is turning into thermal energy, but then that energy is going into the beaker and then into the water. So that is heat transfer. Okay, there are three kinds, and I'm going to show you each one of those. Let me ask you a question. Take a look at this and try to show it to you a little bit. It is a metal probe, solid metal, thin tip, heavy handle. I'm going to set it on here. And I'm going to leave it on here for a while. Some of you might think that's a pretty stupid idea. And you'd be right if I left it on there long enough. Because this coil right here is starting to glow. It's starting to glow red hot. It's really hot. And that means because you know about this first form of heat transfer, you know that I'm going to burn myself eventually if I keep it on there, right? That, my friends, my scientific Spartans, is conduction. Conduction with the D. Conduction. It is the movement of thermal energy through a substance with no movement of matter. So this thing is still a solid probe. It's solid metal. It's not moving into something different. And when I set this on the coil, then the conduction is going from the hot coil. The molecules are moving really, really fast at the edge of this heating coil, and then they're in contact. They are in thermal contact with the molecules in the tip of that probe. And they are getting those molecules to move very fast, increasing the average molecular kinetic energy of that substance, of the tip, and thus increasing the temperature, making it hotter and hotter. Okay? So that is conduction. Now, conduction is also why you guys are worried about me burning my hand. Because when these molecules get hotter, then they're going to transfer that energy along the molecules and that are they're hitting. They're going to get those going faster and those going faster and those going faster, and eventually they are going to get the handle hot, my fingers hot, and I'm going to get a burn. Okay, so that is conduction, the transfer of energy along a substance without the substance itself moving. Next, we're going to look at radiation. I'm actually going to skip the next one because we're going to talk about that last. So, radiation, it makes sense that if I put my hands up above, you're going to actually be able, or I'll be able to feel the heat rising. Heat rises. We're going to talk about that in a minute. But wait a minute. Why can I feel it off to the side? Because of radiation. Radiation is the movement of thermal energy by electromagnetic waves. That the thermal energy, the infrared radiation, is coming off of those coils and going out in all directions. You guys have been to a campfire where you're sitting off to the side. You can get nice and toasty warm even if you're not directly above the campfire. So radiation does not need a substance where it has to travel through. Radiation can travel through the void of space, and if it didn't, none of us would be here right now. It is because this radiation can travel the 93 million miles from the sun to Earth that we are alive. So we are very thankful for the heat transfer of radiation. Our last one you can start to see now. You've got, let me get a flashlight, and you might be able to see that we have steam coming up. Why is that? Well, steam is the stuff moving up. That is convection. Convection is the transfer of thermal energy by movement of a hotter substance from one place to another. The stuff goes somewhere. So right now, I can stand up and I can put my hands up above the beaker and I can feel that heat coming up, and the air molecules are warming up. They're getting more and more active. They're spreading out and they're actually rising because they're less dense. That's how a hot air balloon works. So this is going up. The steam is less dense than air. It's more spread out because each molecule has greater energy. It's starting to go up and up and up. And um, I'm gonna go ahead and give one more example of convection in just a minute, but we're gonna let this get nice and hot, and you can start to see that we're getting bubbles forming here and coming up. Steam and boiling is a whole nother idea, which we're going to talk about later. But right now, I want to make sure you understand conduction. The molecule, the mass is not moving. It is the transfer of energy along a mass or through a mass. Convection, you have the heat rising, but it's actually the mass itself. Steam is mass, air has mass. Those things are rising up and transferring that heat from one place to another. That's convection. And then radiation, if you can see this glowing, it actually, I wonder if you can, I think you can. Yes, let me show you. You can actually see it glowing. That is infrared radiation. And that is radiation, that's thermal energy that is actually glowing red hot. Okay, here's the last thing. I have two things to show you. Number one, here is, and we're going to find a different perspective here for a minute. But I've got two different um, food colorings here. We're going to use blue for the cool and red for the hot. And I want to show you how powerful this whole thing of convection really is, the movement of molecules. So we're going to go ahead and turn this off. And that is off. And now we've got really hot water here. We've got cold water next to it. And I want to show you how rapidly these molecules are moving as opposed to those. The color of the food dye doesn't matter. It's not. It doesn't have any impact. But what we're going to do is we're going to show you this. This is the cold water and the hot water. And I want you to look. I'm going to try to put the drops in at about the same time. And you're going to look at how differently the drops react. So I'm going to put 2 drops in. Can you see it? Right. There we go. I'm going to put 2 drops in. We're going to watch what it does. And I want you to just look at how it moves, or it doesn't. It is moving, but it's going pretty slowly. Let's take a look at the red. Come up here. All right. Ooh, you can see my computer. Look at that. The lensing there. Oh, I love that. Okay, here we go. Watch. 2 drops. 1, 2. And look at the drops moving rapidly. They're being stirred up. You can see the convection currents. It goes down and then and around. And it stirs up because those molecules are moving so fast. They are just going because they have so much average molecular kinetic energy. Look at the blue. Still chilling. Just taking it easy. Moving a little bit because everything does move. That isn't at absolute zero, but look at the red, or the purple, I should say, right? It's already stirred through just because those molecules are moving so fast. All right. So, ladies and gentlemen, I hope you enjoyed our demo. I want you to be able to describe how all of this works. There's our demo. We got a heating plate. We got we got the heating plate, we got the cool water, we got the warm water, we've got all the different things that are talking about heat transfer. Remember, conduction, the mass doesn't move. Convection, the mass does move. And radiation doesn't need mass at all. All right. Good luck on those quizzes, on those questions, and I hope you were enjoying learning about thermodynamics. Talk to you later.